Hello and welcome to this lesson of ventilation and filtration in indoor air quality management. In this lesson we are going to talk about the role of ventilation in indoor air quality, methods to control contaminants, ventilation standards and guidelines, and last the calculation of minimum ventilation rates. At the end of this lesson, you will be able to understand how ventilation systems dilute pollutants and bring in fresh air, to explore different methods to control contaminants, and do calculations following the HVAC standard 62.1. So let's start with a question. Have you ever walked into a room that felt stuffy or uncomfortable, maybe with an odor or dust in the air? What do you think was causing it? So I think we all have experienced this of entering into a room that it doesn't feel like the air feels like they have some kind of dust or sometimes some special odor. So this, where do you think that these particles come from? No, it could be from the outside part of the building. It could be from indoors. It could be something generated inside. But and also whatever is generating these odors or stuffy air, we are gonna notice that it also affects our way that we feel inside the room, our comfort and our ability to study, to focus in what we are doing. This is one of the reasons why it's important, these topics of keeping good indoor air quality inside a place. Let's talk about the role of ventilation in IAQ. So the ventilation plays a key role in maintaining good indoor air quality by diluting indoor pollutants and introducing fresh air from the outside. This fresh air intake is essential to control CO2 levels, maintaining oxygen, and ensure comfortable environments for the occupants. So proper ventilation also helps to control humidity, which is crucial for preventing mold and biological contaminants from growing. There are four main methods to control contaminants and ensure good indoor air quality. First, source elimination or modification is often the most effective approach, as it targets the problem at the source. This can include selecting building materials that don't emit harmful chemicals, eliminating smoking in buildings, or removing hazardous substances like paints and solvents. Next, we have using outdoor air that helps dilute indoor contaminants. Ventilating a space with fresh air is crucial, and but it must be balanced with the need for energy efficiency. Too much outdoor air can increase energy costs, so it's important to regulate the amount of outdoor air based on the contaminants level. Another method is space air distribution, which aims to control airflow to ensure that contaminants don't spread throughout the space. By using different displacement ventilation or localized ventilation, we can capture contaminants before they reach the occupied zone. Finally, we have air cleaning plays an essential role in removing particles and gases from the air. This can be achieved through various filtration methods, including high-efficiency filters, activating carbon filters, or chemical treatments for specific gases. So by combining these methods, we can effectively control indoor air quality and create healthier, more comfortable environments for occupants. So let's talk about ventilation standards and guidelines. The most important that we're gonna talk about is the HVAC standard 62.1 that outlines the minimum ventilation rates required for maintaining healthy indoor air quality in different building types. So these ventilation rates are typically given in liters per second, but I'm gonna mention this unit, air changes per hour, in case you also encounter it. It's also common to express, and this unit means which it indicates how many times the air in a room is replaced within an hour. The ventilation rates recommended may vary depending on the room's function. Offices, it could be offices, it could be classrooms, and residential spaces. And all of these different type of places have different requirements. Before showing you the recommended rates for different types of room, I want to talk about this very important definition, that is the breathing zone. The breathing zone is the region within the occupied space that is within 75 to 1,800 millimeters above the floor and more than 600 millimeters from walls or fixed air conditioning equipment. So this equation here is the way that is recommended by SRI 62 to calculate the recommended ventilation rate in the breathing zone. So as you see, it depends of the floor area, the sun, the population in the zone, and then an outdoor airflow rate required per person in the room, and also a rate required per unit of area. These values, we're going to find them in a table. So this is the table 6.1 of SRI standard 62.1. And you can see that different types of buildings and they have and spaces, they have different values that are recommended. These are the two recommended values that we saw in the previous equation. And also we have a column with the recommended population density, depending of if we have or not the information of the people that is going to be occupying the room. Then in this is a typical error distribution. What I want to show is first this area of here represents a room, and then you see that the breathing zone is smaller than the room, and the reason why there is this definition of the breathing zone is because some of the supply air that comes here, there's going to be a bypass here, and it's going to be this part of the air is going to go to the return fan. So the ventilation rate that we have calculated with the previous equation is this one, so is the equation in this area that also can be related to the ventilation of the supply air. But as we were talking about, what is important for us is the outdoor air. So there is going to be a relationship between the outdoor air that is entering into the zone and the ventilation of the breathing zone. We see here that these two different values, they are related with this effectiveness. That is, we can also get the effectiveness depending of the type of room, and this effectiveness is also in the standard 62.1 for the recommended values. So, for example, if we have a 24 meters square office for one person, and this kind of with well mixed ceiling supply of cool air, then using the equation that we showed previously, and then these values are we have them from the table that we showed before. This is only one person, this is also the recommended value, and this is the area. Then we have the ventilation rate in the breathing zone from outdoor air is this value here. But then, so to relate with the quantity of the ventilation from the outdoors that should come to our system, we have that this value here of the effectiveness is taken from the tables in the 6.4 and is 1. And then with an effectiveness of 1, we are going to have we need 9.7 liters per second of outdoor air that should come to our ventilation system. So as you can see, the lower that is going to be the effectiveness, then we are going to need more outdoor air in comparison with the outdoor air that is entering the breathing zone. So at the end of the lesson, we have some key takeaways. Ventilation dilutes pollutants, so proper ventilation is essential for removing contaminated air and introduce fresh air. So the SRI standards, they have information that help us maintain indoor air quality. And effective indoor quality management relies on a combination of strategies. So controlling contaminants at the source, using outdoor air for dilution, optimizing air distribution, and employing air cleaning technologies. So by integrating these methods, we can create healthier, more comfortable indoor environments that protect occupant well-being and improve overall air quality. And finally, I want to invite you to continue learning with other topics. Like you can explore the indoor air quality management in specialized environments like hospitals and industrial spaces. Learn how to design HVAC systems that balance energy efficiency with indoor air quality requirements. And study the latest air filtration technologies such as high efficiency filters and electrostatic filters for even better IAQ. Thank you for listening to this lesson.